Hi everyone, welcome to the Byte2Beat kickoff for 2026. And thank you all for all who submitted AI for Alzheimer's projects. Results will be released later this week. All of the projects were really good, and I'm super impressed with all the work that you guys have done. And we'll be reaching out to the top performers about publication processes with our partners, which include JEI, and we're also working on solidifying some more. And also, even if you weren't a top performer, but you'd like to expand on your work and reach out to professors, please let us know, and we'd be so more than happy to help. So to start off, Byte2Beat, that's our next hackathon, and AI for Alzheimer's was focused mainly on Alzheimer's and neurodegenerative diseases. So instead, Byte2Beat is more about cardiac diseases, which affect many people. And yeah, and I just want to give a reminder because a lot of people had questions about this last time, and we give example datasets because we want you to feel like what it is to be like an actual computational researcher without having to do the really grunt work of finding your own datasets and cleaning them. But if you really want to have a top tier research project, it's generally better to go find your own datasets and aggregate them because if you have agency of your own data set decisions, you can create the project that you actually want to do, and it'll generally be more novel as well, which is what a lot of journals look for. And yeah. So why this matters, cardiovascular disease is the #1 cause of death globally. And so obviously better predictive models, more precise, is equal to better intervention and more lives saved. And of course, we don't expect you guys to cure cardiovascular disease. That would just be ridiculous. But the idea is that you along with all the other scientists and participants at Byte2Beat can take one step forward in a part of the field. And even though it seems small, it's truly really impactful. Yeah, so all of our data is de-identified and real biomedical data from actual cardiovascular research. Your goal is to generally build ML models. It can be deep learning, typical ML, or something else. Because, another thing is more complexity isn't always better. Sometimes the most simplistic approaches are the ones that actually get implemented in clinical settings. But yeah. And so who this is for, all high school and undergraduate students are welcome. And as well, if you're not in high school or undergraduate, we'd still love it if you participate, but technically you're not allowed to win any prizes. You generally don't need any medical background. We're gonna try to guide you through this process as much as you need. And curiosity is the major thing that you need to have if you want to do well. And just having the drive to persevere beyond challenges and just make sure that you won't just give up, because often it's hard to find what's going to be your differentiating factor, or a type of model won't work, but just being able to push through it, read literature, and see what actually works is super valuable. And what you submit, this is really important, a project report. And I know it says 2 to 3 pages. um that's we had a lot of questions about this last time, and I feel like 2 to 3 pages is just the starting off point. But if you want to go more, definitely go at it. Um, some of the best reports are around 5 to 6 pages, but also it heavily depends. If your novelty isn't necessarily about the model architecture, you don't need to explain all that. But if it is, you should explain. So 2 to 3 pages is just a guideline. It's okay if you go over. Just try not to go full crazy research paper mode. And then we'd also love it if you could attach your code. GitHub or Google Colab or even Kaggle kernels, they all work. And quality is the most important thing, because just because something is complex doesn't mean it's good or publishable. So just make sure you're doing quality work, and you don't have to push for complexity just for the sake of it. Try to actually make something that would advance a part of the field. And this is really important. Please join our Discord. I know I know most of you are already in it, but our Discord is how we give updates and all that. And you can also find the Discord link on the dev post. And yeah, so the deadline is February 28th, 2026, though you have like a couple days grace period. And yeah, the most important thing is iteration. And so if you scan this QR code, yeah, you should be able to see it. And you can go to our Google Drive with already curated data sets. So this one's about cardiac failure, and basically this is just the base data set if you find it useful. Um, it's nice in CSV, and basically it gives a lot of lifestyle habits and all. I would say that this part of the field is generally well understood, but perhaps you could draw some wait, perhaps you could draw some meaningful like connections between them. And yeah, here we've just normalized the columns, this one as well, and yeah, mostly that. Um, so this is like a good starter project. And then here, wait, this one's a little more advanced, and basically it's a lot of statistics about them, and these are like from real clinical trials, and so it gives you all this data. And then you might be confused as to what all these columns are and why there's like three of them. And that's basically because they're we did to them what's called one hot encoding, which basically means because like how it basically came is like you have four different types, but so if you were to feed that into a model, you'd like plug in one, two, three, and four. But models aren't really good at like differentiating like on just a linear scale. So like because I'm not sure if you guys know, but models are mostly affine connections, and then you have nonlinear activations. So it's just better if you like split up um like types into one hot encoders. So that's why we split them into three columns, and that way you can learn more meaningful connections. Same thing here, and yeah. And for these ones, since there was only two categories, we didn't need to split the columns. And this one's also a good one. I would definitely say a little more advanced. But then the most advanced one here probably is the ECG time series, because time series are notably hard to predict, and there's a bunch of ways you can. As, oh, as you can tell, it's a really big file. But basically, this one will probably be the most interesting, and like, but just because it's interesting doesn't necessarily mean it's better results, and it will probably be frustrating to debug. Um, and I think there'd be some interesting approaches. But yeah, and also, I'm not sure if you guys know, but for your AI for Alzheimer's projects, if you've already signed up for an ISAF affiliated regional fair, or if you're even going with your own project, please let us know. We love to hear about your guys' amazing work, and we'd really love to support you in any way we can. And yeah, please feel free to reach out about your successes if you guys get published anywhere. We love to hear about that, and we'd love to feature you on our website. And yeah, thank you. Good luck hacking.